Yeah, in this video, we are going to discuss about functors and lambda functions. And this video is a part one video. So I will upload part two and part three on later on. So before going to the actual topic, I want to show some test case where you can understand more about importance of functors and lambda functions. So consider just a minute. I will increase the font. Yeah, yeah. Consider a vector. I think everyone knows vector. It's one of the standard library template container, STL container, where it's one of the useful array where it adjusts its size dynamically. So you should know the STL basics before going to these functors and lambda functions. So I am just taking one vector which stores the integers. I name it as v, and I initialize it with 1 comma 4 comma 3 comma 2 comma 5, some random numbers. So in this STL, we have containers and we have algorithms and we have iterators. Iterators are basically to iterate, just leave it. And algorithms is to some, you can say some functions, some predefined functions for sorting, for searching, or some different, we can do some operations with these predefined functions. Let me take one of the most important and most useful function, sort, where it will automatically, this predefined function sort our vector or any container. So for this we have to provide a beginning and ending of our vector. Then it will automatically sort the vector and it will provide a result as we can see, after sorting we will get our vector as 1 comma 2 comma 3 comma 4 comma 5 in sorted order. So in this way, we don't know about how it will sort, how it is doing the sorting technique. What is the logic behind it? We don't know. But the thing is, here it's sorting in ascending order. So if we want to sort in descending order, we can't do that in this way because it's by default it's taking to sort our vector into the ascending order. So to sort descending or ascending, we can provide our one more parameter to this sort function. So you can see sort is basically it takes two parameters. So we can also provide three parameters. One is as usual beginning and ending. In third parameters, we can provide some functions or functors or lambda functions as a third parameter where it is useful to indicate to or sort ascending or descending, whichever we need. So here we can provide three types of parameters as a third parameter here. We can provide three types. So here I will say that with increasing part. Yeah, first one is with we can pass some normal functions. Then we can also provide we can provide some functors. Then we can provide some lambda functions. I will highlight this. Yeah, I will make it. Um, I am not getting where to do this. Oh, sorry. Yeah, we can do it like this also. Forgot it. Yeah, I'm going to highlight with the green section. Yeah, we can do it. We can pass as a third parameter. This third parameter with these three main things we can pass it. I think it's better to mark. Yeah, this this third parameter we can pass with the help of these three things. So in this part one video, how I just want to show some only one parameter that is normal functions. In part two, we can see what is functors or how to pass functors as a third parameter. In part three, we can see lambda functions. What is lambda functions and how to pass it into third parameter. So for today, I'm going to show how to use function normal functions as a third parameter. So let me write functions, how to pass it. Yeah, today we are going to see how to pass normal functions. So everyone knows to sort any container, we have to provide two integer two or two elements, because to sort we should compare. So to compare at least we need two elements. So let me take one functions, I name it as compare. Okay, let me take function as comparator or CMP. Some example which takes two elements. One is A, another one is B, and if you need anything, if you need ascending order, you can write like if A is less than B, or else with one line we can do like this: A is less than B. So this expression returns true or false. If A is less than B, it returns true. So in this way it works. But here it returning one bool, so we have to provide as a bool as a return type. So here it is returning bool. It actually need bool, sort need bool. So here if you pass this function name CMP, let me take CMP. If you pass it like this, how it works means first it pass one and two, first two elements one and two. So A is one and B is two. So one is less than two is true. So that's why it provides true as a result. So this sort function understand that it is in ascending order, so it won't change anything. And again it passes two and three as two parameters. Again it returns true or false. If it is true, that means it is in ascending order, so we no need to change. Again it passes three and four. Again it passes four and five. Like that it passes the elements and it compares, and it whenever it returns, I mean it gets true, it won't change. If it gets false, it swap the two things. It how it actually works means like this. So the thing is, here we are writing for, I mean, ascending order. If you want descending order, you can write like this also. There is no problem. For descending order, the only thing is we have to change this. So whenever first element is greater than second element, then only it is in descending order. So it returns true and it won't change anything. Whenever it returns false, then only it change. I mean, it swap the two things. So, but the actual I mean, problem here is we have to write two functions individually, and whenever we need, ascending order, we should let me take it as one. So whenever we need ascending order, we should pass some CMP, or else whenever we need descending order, we should pass CMP one as a third parameter here. So do we have any other options to, take one functions and make it as a generic, and whenever we need ascending or descending order, it should understand that, uh, yeah, and that case, and it should return ascending or descending. So can we do like this? If you say yes, I can say yeah, we can, but not with the normal functions. We can do with the normal functions. We can do with the functors that we will see tomorrow. So if These normal functions, let me take comparator which take int a, comma, int b. If it works like this, yeah, if our function is like this, then it is possible we can make this function as generic function, because here we should provide some condition. Let me take one condition or else bool, which we let me take it true initially. So here we, whenever we need ascending order, we should provide true. Then it execute this line which is written for ascending order. Whenever we need descending order, if we provide v as a false to this function, we can it will execute this thing which is for descending order. So if we have this possibility, it is possible to make it as generic way, but we can't pass this extra element. We can only pass only two elements. This sort function only pass the two elements. With these normal functions, we cannot pass this third element, so it is not possible with this normal function to make it this function as generic for both ascending and descending. We can only do like this with the through two functions. We need to pass for ascending one function and for descending another function. So we can have these functors and lambda functions to make it possible, that we will see for tomorrow, part two video. So yeah, for this video, for our basic understanding, this is enough. For tomorrow video, we will see the functions. Okay, bye guys.